How does matter change phase? In this video, your goal is I can describe how thermal energy affects phases of matter. Remember, thermal energy is heat. So, how does energy affect the phases of matter? Well, first of all, you know that the phase of matter depends on its temperature. You know that your solid ice cream will melt into a liquid puddle if it's a warm day. You also know you could take your liquid puddle and turn it back into a solid by freezing it or cooling it. So, heating and cooling can cause matter to change phases. Heating and cooling can cause matter to change phases. To understand this better, I'm going to show you some diagrams of what atoms look like in each phase. Atoms in a solid have a low amount of energy. So they are moving a little bit. Of course, they're so small we can't see this, but those atoms in a solid are moving just a tiny little bit. They're closely packed together so that the atoms of the solid have a definite volume and a definite shape to them, but they do have a low amount of energy. When atoms are in the gas or in the liquid phase, those atoms are loosely packed together and they have a medium amount of energy. So, this is why liquids can flow, their shape can change, but also they still have a definite volume because they're still pretty close together. When atoms move into the gas phase, now they have a high amount of energy. So they're moving quickly, they're spread far apart, and that's why they don't have a definite shape or a definite volume. So, how does energy affect the phases of matter? Let's look at what happens when you increase the temperature or add thermal energy. When we increase the temperature, let's start with a solid, such as solid water is ice. Its phase change would be called melting, or it melts to make it into a liquid. So a solid melts into a liquid. When that happens, here is solid ice. As we add thermal energy, now those atoms are going to be more loosely packed together. And instead of having a definite shape like a cube, they lose that definite shape and sort of just pile up on the bottom of their container. An example of that is not just ice, but even here is a jeweler taking a solid necklace that was an old gold necklace and using a propane torch to melt it down into liquid gold so that he can shape it into something new. Now let's take a look at what happens when we have liquids changing into gas. So we're still increasing temperature. We can take a liquid, and when we add thermal energy to it, it evaporates into a gas. Liquids, when they're heated, evaporate into a gas. So here is our liquid water atoms loosely packed together without a definite shape. And as we add heat to them, that water starts to turn into steam. And so those atoms will spread farther apart, take up more space, and they will no longer have a definite volume to them. They'll take up as much space as they can in the container. Now let's take a look at what happens when we decrease temperature. I always remember that D for decrease also means go down. So when you remember D, decrease down, that helps you remember that this is where we're going to cool it. So we're removing thermal energy. We're going to start on the right-hand side with the most energy here of a gas. And when you decrease the temperature of a gas, when you cool it, when you remove thermal energy, we call that condensing. So a gas condenses into a liquid. A gas condenses into a liquid. So let's go back to our water vapor in the gas form. As we cool it, we're taking energy away from it. And so those atoms, instead of being spread far apart and moving quickly, they cool down and they gather together in a pile that is our liquid. You'll see this outside in the morning when it's cool. There was water gas, water vapor in the air during the warm day, but then as it cools overnight, that water vapor gas condenses into a liquid, and those little droplets will stick to glass. As we continue to decrease temperature, liquid water can freeze into a solid. Liquids can freeze into a solid. So as we remove thermal energy, liquids can freeze into a solid. So let's start with a liquid that's loosely packed together. And as we freeze it, it begins to get a definite shape as those atoms come closer and closer together. The liquid will freeze into a solid. With liquid water, on a really, really cold winter day, when we pour that liquid water out, it can super cool and turn instantly into solid ice. So check your understanding. Can you describe how thermal energy affects the phases of matter by playing this Kahoot?